In this exponential growth word problem, we'll talk about what would happen if you got a part-time job in high school, saved all your extra money, and most importantly, invested that extra money while you're young. Could you retire with $1 million if you did this? We'll use the compound interest formula to find out. Before we begin, I want to say that I'm not a financial advisor and I'm not offering any kind of financial advice as we do this problem. The point of this problem is to go through the process of solving a multi-step word problem and applying the compound interest formula to solve a problem. That being said, as we work through the problem, I'll do my best to make reasonable estimates. But again, I'm not offering financial advice or saying our results for this problem could be guaranteed to happen. With that being said, let's begin. Here's the situation. You get a part-time job during your 11th grade year of high school, and you're going to keep that job for your 11th grade year, your 12th grade year, and 4 years of college. During the summer, you can work almost full-time, 40 hours per week. During the 9 school months, you'll only work part-time, we'll say 20 hours per week. As we work through this problem, we'll have to make some assumptions. First, an assumption will be how much you get paid. I'm going to make an assumption and use that number for the remainder of the problem. You can use the same number that I choose and work along with me, or you could choose your own. This number will depend on the kind of job that you get and the location you live in. Some jobs pay more than other jobs, and some areas of the country are likely to pay a higher salary than other parts. When you begin your job, you'll very likely be making less money than you're making at the end of the job. Over the course of these 6 years, inflation will cause average salaries to increase, and additionally, as you gain experience in the same job, you're likely to get a raise as time passes. For this problem, I'm going to assume that you make $12 per hour throughout the course of the 6 years. Perhaps you're only making $7 or $8 or $9 per hour when you begin, and by the time that you finish 6 years at the same job, perhaps you'll be making $14, $15, $16 an hour, but I'll say that your average hourly rate during your time at this job is $12 per hour. Another thing that we'll have to account for is the tax rate. At what rate will your pay be taxed at? This will also be determined by the location you live in, because in addition to federal taxes in the United States, you'll also have to pay a state income tax in most states. Because this is only a part-time job and we will not be working full-time for the entire year, your pay isn't going to be that high, and for that reason you won't be taxed at a very high rate. A good estimate at the total amount of taxes you'll have to pay is 12%. Again, this could be higher or lower based on where you live. And the final assumption we'll make will be perhaps the most variable of these 3 assumptions based on who you are individually and your situation. And this is the amount of money that you'll be spending each month. This will be based on your needs and things that you will have to pay, whether you have to pay rent during your time in high school and college, whether you have to buy a car, and also how much money you want to spend on recreation. For this problem, I'm going to assume that you're someone that lives at home while you're in 11th and 12th grade. And if you go to college and live at college, your tuition and room and board will be paid for either by a student loan, by scholarships, by grants, or something that you don't have to worry about each month. And the majority of the money that you spend each month will be on expenses such as a car payment or insurance or a cell phone or various recreational activities. And again, you can choose a different amount for the money that you'll spend each month. This could be higher or lower depending on your needs, but I'll say that each month you spend $600 on food and recreation and perhaps things like a phone or car insurance. I'll say that $600 will be taken out of your pay each week for you to use for daily living activities. Based on these three assumptions, we'll calculate how much you can save from 11th grade until you graduate from college at this part-time job. The first step in determining how much money you can save while working at this part-time job is to determine how many hours you work at the job. Remember, we're assuming that during the summer you can work full-time, 40 hours per week, and during the 9 months that you're in school, you don't want to work full-time if you can avoid it. You'll only work half of those hours, 20 hours each week. Because I want to make this problem realistic, we'll build in some vacation time for you. You certainly would not want to work at a job every week of every year for 6 straight years. What I'll do as I do the calculations for the amount of money you can save while working at this job is I will assume that there are 4 weeks in each month. Now in reality, there's more than 4 weeks. There's a few days more than 4 weeks in each month. If I'm assuming 4 weeks in each month times 12 months in a year, that means that you'll be working for 48 weeks each year. Now a year actually has 52 weeks in it, so assuming that there are 4 weeks in each month will allow you to be taking 4 weeks of vacation, or about a month's vacation each year, which is reasonable and something that you really should do if you can, to not work every week of every month for the entire year. So with those assumptions in mind, let's first determine how many hours you would work during one school year. During the 9 months that school is in session, how many hours would you work in a year? Well, there are 9 months in the school year, and during those 9 months, we're going to assume that there are 4 weeks in each of those 9 months, and during each week, you'll be working 20 hours, and that product, 9 times 4 times 20, is 720. So over the course of one school year, over the course of one set of 9 summer months, you will work 720 hours. How about during the summer, when you work 40 hours per week? Well, over the course of a year, there are 3 summer months, and in each of those months, there are 4 weeks, and in each of those weeks during the summer, this is when you'll be working full-time, 40 hours a week. This product will be a little less than 720. 3 times 4 times 40 is 480 hours. So over the course of a year, during the 3 summer months, you will work 480 hours. So now let's answer the question. How many total hours would you work over the entire 6 years? Well, first, the total hours you will work in 1 year is 720 plus 480, which is 1,200 hours. So each year you'll work 1,200 hours. And so if that's how many hours you're working each year, and in this problem we're assuming that you have this part-time job for grades 11 and 12 and 4 years of college, 1,200 hours per year times 6 years gives you a grand total of 7,200 total hours worked during your time at this part-time job. Now that we know we'll end up working 7,200 hours, we can use that information to find the gross pay, the net pay, and how much we're left with after expenses. Remember that we're going to be working for 7,200 hours at a rate of $12 an hour was our assumption. We've assumed that the tax rate is 12%, and we've assumed that our expenses were $600 per month. The gross pay will be determined is the amount of money that you get before taxes or expenses. And over the 6 years, if we're working 7,200 hours times $12 average hourly rate for each hour worked, that's a grand total of $86,400. We're not going to be able to keep all of that money because that money will be taxed at a rate of, we're assuming, 12%. So we'll take our $86,400 and subtract from that 12% of, in mathematics, the word of always means multiplication, 12% of 86,400. And that difference is $76,032, the amount of money you'll make over the course of 6 years at this part-time job after 12% is paid in taxes is $76,032. Now, realistically, even though that's the amount of money that we'll get on our total, on all of our paychecks, we're not going to be able to save all of that money. Everyone's expenses are going to be a little different, but again, I'm assuming for this problem that your expenses are $600 each month. So the amount of money that you will save after monthly expenses would be the $76,032, but then we'll have to take away $600 for each of the 12 months in a year for a total of 6 years. And what we're left with is $32,832. So this is the amount of money you can save from working a part-time job from grade 11 through 4 years of college if your average hourly rate is $12 an hour, the tax rate is 12%, and your expenses are $600 a month. Now, let's use the compound interest formula to see how much this amount can grow to if we invest it for the long term. Let's say that you graduate from college at age 22 and you take that money that you've saved and you invest it in an aggressive long-term mutual fund which earns an annual rate of, well, we're going to have to make another assumption. Now, again, I'm not a financial advisor, and the purpose of this problem is just to practice using our math skills to solve a problem. But let's try to be reasonable. An aggressive, and the important thing is long-term mutual fund, long-term, can be expected to earn something like 8 or 9% interest each year. The return on a long-term aggressive mutual fund could reasonably be assumed to be 9%, and that's what we'll assume for this problem. Let's say we keep that invested for a long time. Let's say we invest our savings from our part-time job at age 22 and we let it grow until age 65. How much money would be in the account at that point? This is where we're going to use the compound interest formula, which is A of t equals A sub 0 times the quantity of 1 plus r to the power of t. In this formula, A sub 0 represents the initial amount of the investment. R is the rate of growth, and that's a percentage that's written as a decimal. And t is time. And because our interest rate is an annual rate, this t will be measured in years. Our initial amount in this problem is the amount of money we've saved from our part-time job. The interest rate is the assumption we've made of 9%, and the time is the number of years from age 22 to age 65. So in our case, it will be 65 minus 22, which is 43 years, is the length of time that we will have this money invested. Substituting those values. After 43 years, the amount of money we'll have after 43 years is equal to the initial amount. Remember, Based on our assumptions, we calculated that after taxes and expenses, we would save $32,832 times the quantity of 1 plus 0.09, that's 9% written as a decimal, to the power of t, 43 years. This 43 represents the number of years from age 22 to 65. This computation will best be done using a calculator, and it equals $1,335,478. If $32,832 is invested at a rate of 9% for 43 years, the ending amount will be $1,335,478. Before I end this video, I'll say that we have not accounted for a few things in saying that this money will grow to $1.335 million. If you would invest this in a mutual fund, it would be taxed as it grew, which would slow down the growth rate. Additionally, if it's invested in a mutual fund, that mutual fund will include some fees associated with it. That will be taken by the people that run the fund and decide what stocks to buy and sell to be part of the fund. So this number is assuming that there's no taxes as it grows and there's no fees on the mutual fund. But again, the purpose of this problem wasn't to, again, I wasn't offering financial advice. The purpose of this problem was to work through a multi-step problem, apply the compound interest formula, and show the power of compound interest. The reason that our $32,832 grew so much to a large amount, over $1 million, was that the value of T, the time that it was invested, was 43 years. You only get one chance to invest money over the long term, and that's when you're young. If you wait until you're 40 or 50 years old and plan to retire at age 65, the money won't grow to nearly as large of an amount. But again, assuming no taxes and no fees on a mutual fund, an investment of $32,832 at 9% over 43 years will grow to $1,335,478.